Hey everyone, this is Miss Helms, and today we are going to discover our formula for the area of a parallelogram. So we are going to start with a new sketch in Geogebra, and what we are going to do is we actually want to view both our axes and our grid to help us calculate the area formula a little bit easier. So once those are on, one other criteria we want our point capturing to be snapped to grid, just so that our points lie on our grid lines for easier calculations. So once we have all of that set, we're going to start by creating a rectangle, which is something that we did in chapter 3 with our constructions unit. So start with a segment AB on your grid, and then go ahead and create perpendicular lines. So you want a perpendicular line through point A to segment AB and through point B to segment AB. Then you want to create a point anywhere on your perpendicular line through point A and create the perpendicular line through point C to line AC. Then go ahead and create your intersection point of your two perpendicular lines, followed by your segments AC and BD. So since we have those segments created, we can go ahead and hide your perpendicular lines. So you should have just the bottom three segments of your rectangle and then one line for your rectangle. Also, we are going to change the names of the segments of your rectangle, which will help us for the area formula. So you want to right click on segment AB, go to Object Properties, change the name to Base, and then select segment E and change this to Height. And you want to make sure Show Label is checked so that you will see that when we view it in this screen. And let's go ahead and create the interior of this rectangle by using our polygon tool and selecting the 4 vertices in order. Once we have this, one awesome thing about GeoGebra is that it will calculate the area for us. However, before we do that, we know our area formula for rectangles. So go ahead and write that down on your investigation. Okay, so hopefully you filled in your area formula for a rectangle, and GeoGebra will calculate that for us by going to our area tool and selecting the interior of our polygon. So the area for our rectangle is our base times our height, which would be 32 units. Next, what we want to do is discover the area formula for a parallelogram. So to do that, we are going to create a parallelogram that has the same base and height as our rectangle to see what formula we can come up with. So to do that, we're going to start by constructing a point on line CD, point E, and then construct segment AE. And since we want a parallelogram, we need 2 pairs of parallel sides. So go ahead and construct a parallel line to segment AE through point B. And then construct the intersection point of your parallel line and line CD. Now that we have our parallelogram, we can go ahead and create the polygon interior of this by using our polygon tool and selecting the vertices in order. So A, then E, then F, then B. Last but not least, back to A. And to show the difference between the two polygons, what we want to do is change the color of your parallelogram, the interior, to anything you want it to be. The next thing we want to do is calculate the area of this parallelogram just like we calculated the area of our rectangle. So using the area tool, select on the interior of your parallelogram. And then what we want to do is go ahead and drag point E to figure out the relationships between the area of our rectangle and the area of the parallelogram. So some ideas we want you to take a look at is, what do you notice about the area of the rectangle and the parallelogram as you move point E? Also, what do you notice about the triangles that are formed in this diagram? So we're specifically talking about triangle ACE and triangle BDE. Using this information, go ahead and complete your investigation.